taking a look at our ionic solubility, or solubility of ionic compounds. For this lesson, make sure that you have your periodic table in front of you, your Nelson periodic table on the back. Top right corner has the solubility of some ionic compounds in water at 298.15 Kelvin. That's the chart that we're going to use here. Using the solubility table on the back of your periodic table, we're going to find the anion, or nonmetal, or polyatomic, along the top of the chart. We're going to find the metal ion in the following rows, and if it doesn't appear, we assume it falls into the most category. This is a representation of your your solubility table from Nelson. Unfortunately, it doesn't match exactly, and the other one was a little hard to read here, so I'm using this. Things to note in our table. Well, ions are listed across the top. These are all negative ions for the most part. So we're always looking for our anion, or our negative ion, across the top. Listed below, we read down the column. These are all where our positive ions are listed. What we can see is that the first row, things are very soluble. This means that if our compound is made up of the anion and the cation, or positive ion, from this row, we can say that it is aqueous. It will dissolve in water. Our second column here, or second row, says slightly soluble. This means that very few particles dissolve. However, the most of them don't. If that's the case, most of them remain as a solid, and we say that this is insoluble. Insoluble doesn't mean that absolutely none dissolve. It just means that the majority of them do not. Okay? Most of them will sit at the bottom of a solution. Maybe one got to dissolve. So we're going to use this table to decide on the solubility of silver chloride, aluminum acetate, and lead 4 sulfate. Let's get started. So silver chloride. Let's write the chemical formula for this first. It's a lot easier to match with what we're looking at in our table. Silver chloride is composed of a silver ion and a chlorine ion. With that, we would write it as AgCl. A positive one and a negative one totally balance out without any subscripts. So what we need to do is we need to find our anion, or the ion listed second, along the top of our table. Now, again, this is slightly out of order, but the rest of it is the same. So we find chlorine first in this table. So most things with the chlorine ion are soluble. Let's double check to see if silver is part of the insolubles. I can see that silver is actually listed first, meaning silver doesn't fall into the category of most. Silver chloride is considered insoluble. So if I were to write it in solution, I would say that silver chloride is a solid. Aluminum acetate. Aluminum, as an ion, is a 3+. Acetate is a polyatomic ion. So we need to find it in the polyatomic ions. It's the first one there. CH3COO-. So to balance charges, aluminum is a 3+ and acetate has a 1-. I'm going to need 3 acetates to balance aluminum's charge. I need brackets to put around my polyatomic ion, and let's check to see what its solubility is. I'm going to look for my anion, or the negative, across the top. I need to find the row, or column, where acetate is listed. CH3COO- is listed here. Most things with acetate are soluble. Let's just double check that aluminum isn't one of the exceptions. Silver is an exception, and mercury 2+ is an exception. However, aluminum is not. Therefore, I can assume that aluminum falls into the most category. Therefore, aluminum acetate is soluble in water. if aluminum acetate was placed in water, I could write its state as aqueous. Lead 4 sulfate. Lead 4 is Pb4+. Sulfate is a polyatomic, SO4 2-. So to balance for charge, I need 2 sulfates to balance the 4+ charge from lead. So PbSO4 2. Remember, if you're dropping crossing here, that'll still work. The 2 comes down to lead and the 4 comes down to sulfate. However, because both 2 and 4 are divisible by 2, we will leave this as Pb1, which we don't write, SO4 2, which is what I just wrote. Okay, back to solubility. We need to look for sulfate along the top of our chart here. Sulfate I find here. Most things are soluble with sulfate. However, let's see if Pb4+ is an exception. So silver, Pb2+, calcium 2+, barium 2+, strontium, and radium are insoluble with sulfate. Now, lots of us see lead and we think it's insoluble. However, lead has multiple charges. Different charges can have different solubilities. So, because this says Pb2+ is insoluble, but I have Pb4+, Pb4+ is included in our most. Therefore, lead 4 sulfate is soluble. If lead 4 sulfate was put in water, its state would be aqueous. If I had lead 2+ with sulfate, so I had PbSO4, this would be insoluble because we have the Pb2+ ion and it would be a solid if tried to place in water. So be careful of charge. Different charges can have different solubilities. Complete the table for practice in your booklet.